we will also tell you what is the relation between the electric current, electric charge, current density and conductivity. Consider a conductor of length L and the ends of the conductor are connecting with this battery of voltage V. This conductor consists of an atom consists of proton and electrons, so there are number of electrons in this atom, in this material or in this conductor, you can say. These electrons, on applying of this external source of battery, these electrons starts moving from low potential to high potential. So there will be a movement of these electrons towards this direction, and when these electrons move from end B to end A, there is a velocity of these electrons, and this velocity is called Vd. This Vd velocity is known as drift velocity. So these electrons will move towards A end with drift velocity Vd. Length of the conductor is L. So in this conductor, suppose there are n number of electrons. How many number of electrons? N number of electrons inside this conductor, and charge on one electron is E. Charge on one electron is E. So total charge will be how much? Charge on one electron is E, and there are n number of electrons, so total charge will be n into E, right? So this is the total charge. And what is current? I have defined current is dq by dt, or what will be the instantaneous value? You can say q by t. What is t? T is the time, and time is t here. So how to define drift velocity? Drift velocity Vd is nothing but the distance travelled by the electron in a given time. So distance means, what is the distance here? The length of the conductor is L. So suppose one electron starts moving from end B to end A. So how much distance will be covered by one electron is L. In what time? Suppose time is t. So Vd is L by t, meter per second. I have taken meter, distance in a meter. But in circuitry, there are conductors of very small length, nanometer, micrometer or millimeter. So here we are taking the standard length, standard unit of the length. We will see the smallest unit further in further lectures, right? So Vd is L by t, and charge Q equals to E. So what will happen? I equals to total charge is N E, Q equals to, you can say, total charge Ne. So Ne divided by time, and from here time is L by Vd, right? So now you have Ne Vd by L. this is one relation of current and electronic charge. Now, suppose in this conductor the cross sectional area is A. This is the cross sectional area of the conductor. So what is the relation between area, length and volume? Volume is area into length. Okay. So here length is volume by area. Length equals to volume upon area. Now see here, I equals to NEVD. This is volume area. Now there are two terms which I am going to define. Number of electrons divided by volume is nothing but small n, that is electron concentration, or you can say concentration of electrons, right? And if we combine this Ne upon volume, or you can say small n into E, it will give you the electron charge density or charge density. आप कुछ भी कह सकते हैं, electron charge density or simply you can say charge density. So charge density is nothing but what? Number of electrons per unit volume. So it will be coulombs per meter cube, N into E. And electron concentration is N upon volume, that is small n, right? So now this equation will become I equals to, if you write NEAVD, if you write in terms of electronic concentration of electrons, then this one, otherwise, or I equals to, and this charge density is denoted by rho. So we can write rho AVD. This is another relation in terms of charge density. Or here divide this current by area. So on this side rho times Vd, that is drift velocity, and this is equal to J, that is called current density. So J is rho Vd. Okay. So this is the relation of current in terms of electron concentration. Here relation of current in terms of charge density, and here this is a relation between the current density in terms of charge density and drift velocity, where Vd is the drift velocity, right? So these relations are very important, and these relations are the foundation of the current properties in the material. Okay, so there are properties which I told you, that charge is a property of matter. If material exists, then there will be a charge. If charge exists and if you apply some external energy source, then current will flow. If current will flow, then there will be a current density. Okay, that is J. Now consider an example. So focus on this example. a conductor material has a free electron density of 10 raised to power 24 electrons per meter cube, or you can say these are the number of electrons per unit volume. So what is given? Here given free electron density, or you can say concentration of electrons. So electron density or concentration of electrons is what? 10 raised to power, that is n, 10 raised to power 24 electrons per meter cube. So this n is nothing but number of electrons per unit volume. Then when a voltage applied, जो अभी आपने देखा था कि जिसमें हमने कंडक्टर लिया, इस कंडक्टर में जब हमने वोल्टेज अप्लाई किया, यहाँ देखिए आप, यहाँ पर जब हमने ये एक्सटर्नल वोल्टेज अप्लाई किया तो ये इलेक्ट्रॉन्स बी एंड से ए एंड की तरफ मूव करने लगे. तो जब ये मूवमेंट स्टार्ट हुआ आफ्टर अप्लाइंग ऑफ दिस वोल्टेज, देन देयर इज अ movement in electrons, and this movement is denoted by the drift velocity Vd. So it is given in this example what? When a voltage applied, a constant drift velocity of 1.5 into 10 raised to power minus 2 meter per second is attained. So drift velocity is given, and this drift velocity Vd is what? 1.5 into 10 raised to power minus 2 meter per second. एग्जाम्पल, जब भी आपको कोई न्यूमेरिकल प्रॉब्लम्स आती हैं तो आप उसकी एक एक लाइन पहले ध्यान से पढ़िए कि क्या प्रोवाइड किया गया है और क्या आपको फाइंड आउट करना है. इफ द क्रॉस सेक्शनल एरिया of the material is 1 centimeter square. So cross sectional area is denoted by A, and this is 1 centimeter square. So convert it into meter square, because electron concentration is given per meter cube, drift velocity is in meter per second. So convert this area in meter square. 1 centimeter is equal to 10 raised to power minus 2 meter. So it will be 10 raised to power minus 4 meter square, right? And charge on one electron is 1.6 into 10 raised to power minus 19 meter per second. Sorry, not meter per second, it is coulomb. Okay, you can write C also. So this is charge on one electron. Now you have to find out current. So this current is I equals to N E A V D. N is charge on one electron is area 10 raised to power minus 4 meter square, and V D is 1.5 into 10 raised to power minus 2 meter per second. So this current is now 0.24 ampere. Okay, so this is a very basic and simple problem based on direct formula, but from here you got the concept कि क्या क्या दिया हुआ है, कैसे आपको जज करना है कि इलेक्ट्रॉन कंसंट्रेशन ही गिवन है या फिर ड्रिफ्ट वेलोसिटी ही गिवन है. तो इलेक्ट्रॉन कंसंट्रेशन को आप इलेक्ट्रॉन डेंसिटी भी बोल सकते हैं, क्योंकि डेंसिटी इज नथिंग बट नंबर ऑफ इलेक्ट्रॉन्स पर यूनिट वॉल्यूम. Now consider another example. Now consider this example. Find the velocity of charge leading to 1 ampere current which flows in a copper conductor of cross section 1 centimeter square and length 10 meter. तो यहाँ पर आप देखिए, पहले इतने पार्ट पर आप फोकस कीजिए. एक कंडक्टर है, सपोज दिस इज अ कंडक्टर, दिस इज अ कंडक्टर. The length of this conductor is 10 meter and cross sectional area A is 1 centimeter square. In this you have to find the velocity of charge. So velocity of charge, drift velocity, Vd you have to find out. Current in this conductor is flowing I equals to how much? 1 ampere. So current is here 1 ampere. Free electron density of copper is, again electron density, it is saying electron density means number of electrons per unit volume, that is N. It is given 8.5 into 10 raised to power 28 per meter cube, means number of electrons per meter cube. This is electron density. How long will it take the electric charge to travel from one end of the conductor to other? Suppose this is end X, this is end Y. So these are the electrons inside the conductor, and electrons are moving from end Y to end X. That's why current is flowing from end X to end Y. So how much time electron will take from end Y to end X? Suppose that time is T. So you have to find out T. Now we have relation I equals to NEA VD. Okay. So current is given how much? 1 ampere. Electron density 8.5 into 10 raised to power 28. Electronic charge means charge on one electron is 1.6 into 10 raised to power minus 19. Area is 1 centimeter square. So area is equal to 10 raised to power 4 minus 4 meter square. You can write here into VD. So from here you can find the value of VD, that is C. This is micrometer per second, or you can say into 10 raised to power minus 6 meter per second, because 1 micrometer equals to 10 raised to power minus 6 10 raised to power minus 6 meter. Now next part is what? How long will it take from one end to another end? So suppose that time is T, and I told you time is what? Drift velocity equals to length per unit time. So time is what? Length per divided by drift velocity. And what is length? Length is 10 meter. Drift velocity is this one. Okay. So it will take T equals to 1.36 into 10 raised to power 7 seconds. So this time is very high. Okay. So I am not focusing on the value of time because the parameters are given randomly. So this time is very high, means it will take so many years. 10 raised to power 7 second. 10 raised to power 7 is a very big quantity. But focus on how to, means how we have calculated this, right? So these are basically this is the way to find out the different parameters by this formula. Okay. So अभी तक हमने देखा इसमें चार्ज क्या होता है. चार्ज इज अ प्रॉपर्टी ऑफ अ मैटर. Current is flowing in the circuit due to movement of charge. And what is current density? Current density is the current per unit area. Electron density or concentration of electron is number of electrons per unit volume. And what is the drift velocity? Drift velocity is the velocity by which charge is moving inside the conductor, right? That may be a wire, that may be some conducting bar. Okay.